Welcome to Maths with EJD. In this video, I'll be talking about I'll be talking, starting from this video actually, I'll be talking about some basic theorems in graph theory, basic theorems in graph theory. There are three of them I'll be considering, but I'll take them in separate videos. But the first one, okay, well, let me even talk about the basic theorems, right? Let me start out by talking about those basic theorems of graph theory. Uh, One of them is what we are considering now, which is the handshaking lemma. The handshaking lemma. Okay. Apart from the handshaking lemma, we also have Euler's theorem. We have Euler's theorem. It will look like Euler has something to say about every aspect of mathematics, and that's talking about Eulerian parts and circuits. Euler's theorem relating to Eulerian parts and circuits, and of course we have Hamiltonian cycles, something related to Hamiltonian cycles. Of course, you already know what a cycle is based on what we had done previously. So, and this will be Dirac's and Oris. I don't know how this is pronounced, Oris or Oris, I don't know, theorems. And that is related to Hamiltonian cycles, like I said initially, Hamiltonian cycles. Okay. So these are the basic theorems. So I'll be taking them one after the other in this, as we continue. So the focus today is on the handshaking lemma. It's a very sweet and simple theorem in graph theory. Let's look at that. The handshaking lemma. The handshaking lemma. Okay. So, and what does the handshaking lemma say? Um, Basically, right? The the handshaking lemma, the handshaking lemma states that the sum, the sum of the degrees, the sum of the degrees of all vertices, okay? The sum of the degrees. Let me emphasize this. Let me just emphasize this somehow. So the handshaking lemma states that the sum, it states that the sum of the degrees of all vertices, okay, in a graph is twice the number of edges, is twice the number of edges. That is what the handshaking theorem, the handshaking lemma states. The sum of the degrees of all vertices in a graph, in a graph, in a graph is twice the number of edges. Okay. Now, uh, mathematically, right, that simply means that the summation of, so if we take a small v belonging to the set of vertices, so the degree of the sum of all the degree of v is simply 2 multiplied by the number of edges. That's the summary of what that is about. So this also implies, this also implies that the sum, okay, this also implies that the number, right, that the number of vertices, the number of vertices with, the number of vertices with odd degrees, the number of vertices with odd degrees in any graph is always even. It's always even. So this is more like a corollary to the general one, that the sum of the degrees of all vertices in a graph. Okay, this is looking like they are too close together. So vertices in a graph, okay? So the sum of the degrees of all vertices in a graph is twice the number of edges. So this simply means that this also means that the number of vertices, right? If you have vertices with odd degrees in any graph, this also implies that the number of vertices with odd degrees in any graph is always even. So if you have odd degrees, you are always going to have even vertices because the number of vertices, right? The sum of the degrees of all vertices in this graph is twice the number of edges. Okay, so to drive home the point, let's consider an example. Okay, so imagine this. Consider a graph. Consider a graph vertices with vertices V, which is and vertices are A, B, C, D. Okay, and edges E. So E is a collection of the edges. So we have edges A, B. That's one of the edges. You have B, C. Okay. You have C, D. You have D, A, and you have AC. Okay. These are the edges. So imagine this now. Well, if you want to, I think it's always excellent to visualize. So imagine we have this. So it's A, B, our usual A, B, C, D. So these are the vertices. Then what are the edges? We have AB, we have BC, we have CD, we have DA, we have AC, like this. But there's no BD, right? There's no BD. Okay. I mean, this is what we have. No BD. So what does this say now? What is the degree of A? It is an undirected graph. Okay. So, um, okay, we want to establish, we want to prove this. Okay. All right. So we'll just say to prove the handshaking lemma, to prove the handshaking lemma, okay, to prove the handshaking lemma, what happens? So, what is the degree of A? Degree of A. The degree of A is the number of edges connected to A, right? So if you look at A now, the degree of A is 3. So you have an edge coming from B, an edge coming from C, an edge coming from D. So the degree of A is 3. Now the degree of B, what is the degree of B? The degree of B is simply 2. Okay, coming from C and coming from A. So the degree of B is 2. What is the degree of C? The degree of C is also 3. The degree of C is 3. And the degree of D is also 2. It's 2 like degree of B. So that's 2. So now let's see the sum of this now. The sum of what does the formula say? The degree of V now. Degree V. So if you sum all that up, right? So that's like the degree of A plus the degree of B plus the degree of C plus the degree of D. Okay? That simply means we have 3 plus 2 plus 3 plus 2. And that is simply 10. So you can see that the sum of the degrees is basically 10. Okay? So the sum of degrees is 10. The sum, the sum of the sum of degrees is 10. Okay, that is established. So what do we do? Um, how many edges do we actually have now? How many edges do we have? Mm, so the number of edges, the number, yeah, I guess I want to switch things up here. So the number of edges, the number of edges is equal to, this is how you demonstrate that the number of edges. So how many edges do we have? We have 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So we have 5 edges. And what does that mean? So you'll see that therefore, the summation of this, of the degree of the vertex, of all the vertices now, you know, is actually equal to 2 times the absolute value of the edges, okay? Which is actually uh 2 times 5, and that is 10. So that establishes the handshaking rule. Okay? I mean, can we just take a random, like a random example? This is totally unplanned. So let me just try that out and see what happens. Mm, another, okay, let me call that random example. This is just a random example. Okay, more intentional, random example. So I'll just draw any link, any graph, okay? So imagine we just have A, B, C. So we have, okay, let me just say 1, 2, 3 now. Okay, let's say there are 3 friends. There is there is um Bose, there is Chioma, and there is Dunia. I mean, let's just take that. So these are 3 friends now. So um Bose is friends with Chioma. Bose is friends with Dunia. Dunia is friends with. Okay, let's just even leave it this way. We are used to everything being connected. So let's just say this is what we have, right? So what happens? So the summation of the vertices, you know, the degree of the vertices would be, so that's the degree of B. So that's the number of friends Bose has plus the number of friends Chioma has plus the number of friends Dunia has, right? So the degree of Bose has two, 2 connections. It's more like you can even imagine it as as a social media thing. So the degree of C is actually 1, okay, because Chioma has only 1 friend and Dunia also has only 1 friend. So that is actually 4 in all, right? So but then, what is the number of edges? Okay, we have the number of edges is actually 2. Okay, so the absolute value. Okay, let me just say number of edges is equal to this, which is simply 2, and so therefore the summation of the degree of the vertices of all vertices is actually 2 times this now. That means you have, I mean, it's basically 2 times that. We can stop at that. In fact, if I just imagine, I'm just imagining that if we closed this up, right? So it means each person has 2 friends. That's 6 in all, and there are 3 edges. So 2 times 3 is 6. So the handshaking rule is very simple, straight to the point, and that is it for this video. So I mean, just draw any random graph and try out the handshaking rule. You see that it makes a lot of sense. I mean, I'll be talking about the next theorem in the next video. That's Euler's theorem relating to paths and circuits. So if you have not subscribed to this channel, be sure to do that right away. Hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know if you want me to teach a topic or solve a problem. Then share, like and share so that more people can have access to this great learning. Till I come your way again, keep connecting. Bye.